All right, so hello everybody. Okay, so based on the notes, I need you to refer to notes anyway. Okay, can I have you look at notes? Your notes. Let me explain to you how this thing works. Okay, and also, I try to cover more so that to study less on yourself and everything. So now, definitely in these notes, right? Already expected some of the questions. I leave it to you because don't worry about that. Because after that, you get answers. Don't worry about that. Okay, whether you are TDC students or you're non-TDC students, right? Anyhow, we upload answers one. Okay, so the questions you can try doing yourself afterwards. But the main thing is, of course, we need to revise first, because if I go to the question straight away, you'll be very very blur, right? Like you don't know this one, you don't know that one. So might as well I spend some time explaining or even reminding you, because I suppose most of you been through chapter 1, been through chapter 2 already, right? So what we're doing is a bit like a revision thing, okay, to prepare for your first term exam. And to be quite honest to you, your first term exam is probably the exam that you have the highest chance to get high marks. Because why? Normally, first term exam, right? They don't really have full format paper yet. Means you're not gonna have all 3 paper. Second thing is what? You might not be having a lot of papers. You might not be having a lot of chapters. Most probably what? Chapter 1, chapter 2, that's it, right? So lesser chapter means what? There'll be more there'll be more time for you to study, because you practically only have to study like what, 2 chapters. So what I do here, I kind of prepare for you, all right? So whether I go through or not, I give you extra one definitely. So the question behind these are very, very good questions that you can practice on yourselves. And also there will be answer provided to you, so you don't have to worry about that. You see all these questions here, these are all the exam style questions I put inside. And among some of the questions is for you to try yourself, and for you to try to attempt yourself. You can try doing yourself. Okay, and those are very good questions you could try on. And but before that, right, I suppose the very first page you see this, am I right? You see, I gave you like an A+ checklist for you, right? Now, this checklist, very simple one. You got chapter 1, and then you got additional part, and then also you got chapter 2. So what I do, very simple. Now I go very detailed, because why? I want you to be able to understand this. I want you to be able to actually, go through this. You can read this on yourselves. You can actually go through this on yourselves, that you don't need to explain very, very detailed. Okay, so this is more like a reading material for you, a checklist. Now, why the checklist? Simple. I get this a lot. Most of you will tell me one simple thing is that, not that I don't want to study. I don't know how. I don't even know how to start. I don't even know where to start, and I don't even know what to do. Now, simple. This is your study guide. Okay, basically, I'm telling you what to study. What is the thing that you must know before you go for exam? Now, I suppose there's only 2 types of person now, right? Now, number one is you haven't even started yet, right? You are preparing for an exam, but you don't even know where to start. You've got no idea. There you go. Follow this checklist for you. Okay, go through one by one. Now, some of you probably started studying. Okay, some of you say, oh, I want to score very high this time one. So I started study like 2 weeks before. That's very good for you. Now, for those who actually started studying, right? I suppose one of your biggest worry is what? You, not to say you don't study. The problem is what? When you study, right? You not too sure whether your exam, whether whatever you study is enough or not. You feel like finish already, but then you constantly worry you miss out one or two. And then exam come out the one, and then you got, right? And also sometimes, right, you're studying in a wrong way. As in, when you look at a textbook and you look at a reference book, right, especially this for form, like a new thing to you. You don't even know what is coming out for exam. You don't even know how the exam is going to be like, right? So the idea is, what I do, I let you know what is important, what is the thing that you need to know, what is less important. Because some of you, right, you wasted like what, half a day to study something that don't even come out in the exam. Because why? You just see your textbook, you read your reference book, they give you like a lot of detailed explanations, and you feel like, oh, this is important because they explain so much. Not necessarily one. Yeah, sometimes, right, they talk a lot, but then end up, right, exam come out what? 1 question, 1 mark, 1 objective, that's it. So a big waste of time. So you need to know what to study. You need to study smart, as in that strategy. What is the main thing to study? What is the important thing that you should study? You seeing idea? Something like this. Okay? Now, so what I do here, I prepare for you is, it's like a checklist for you. Now, what you can do, very simple. Number one, right? After that, when you settle the class, you go back. At home, what you do, right? You try to go through the checklist on yourselves. Okay. Now, you don't even have to show me. So what you do, very simple. You just go through this, and then you be honest to yourself. If you are clear, let's say for example, for chapter 1, you remember the base and derive thing. So if you tell me that I am very clear about base and derive, I know exactly I got 7 base, and then I remember all 7 of them, and then I know how to differentiate between base and derive. Simple. If you are clear with that, you put a tick there. Exactly. So while you go through, right, the first time, of course, there'll be something that is unpicked on. And those are the things that you miss out. Those are the things that you go and find out more. Look at your reference book, look at your textbook, or even look at your notes, whatever also can. Okay, you try to recap those. Now, once you're done revising that, then again, you put a tick there, you put a tick there. So ultimately, right, your checklist should be something like that. It should be full of ticks. So by doing that, right, in a way, you will feel more and more confident about yourself because why? You know you are making progress. You know that you are studying for an exam. So, and also second thing, you know that you're not going to miss out anything, randomly they surprise you in the exam. Exactly. So the idea of checklist is like that, to let you know what is coming up and then what is important, what are the things that you need to study. So you can see this as a study guide. You can see this as a, as a reference. I tell you what to study and how to study accordingly. And then you see, I make it very, very detailed one so that you would understand what I say here. Able to differentiate the difference between scalar and vector and then give example of scalar and vectors. So what I do, I go through one by one. Now I roughly go through, and don't worry, this is only like a summary, right? More like a checklist. After that, right? After you go through this, of course you ask, hey, I need those notes. How? These are the things that I kind of give you a short notes, so you can go through, prepare all the important notes for you. Yes, now there you go. Motion graph also I can provide. So you can also read through the detailed version after that. And also one more thing, you go to your page number 5. You will see one page like that. It is. This is the definition list. I only put in chapter 1 and chapter 2. Yes, because why? Most of you have an exam until chapter 2 only. So do we have more? Of course, chapter 3, chapter 4, chapter 5. Every chapter got definitions on. And also, right? For definitions, for whatever subject, chemistry, bio, physics, they like to ask definitions on. Okay, so I'm telling you that definition confirm come out. You want to memorize or not, your choice. But the idea is whether I give you a simple information. Definition confirm come out. Okay, but then right, every time exam come out, they will normally, on average, they come out about 5 marks. Exactly, on average, they will come out about 5 marks like that. So you decide yourself whether this 5 marks important for you or not. I mean, you memorize, you get the 5 marks. If you don't memorize, right, you lose 5 marks. So some of you say, never mind memorize so many for the 5 marks, I throw away . Now, if you're gonna do that, then here's the thing: you need to make sure you actually got. You need to make sure you actually got 95. As in like the rest of the mark, you need to score. Exactly, because some of you you're very generous one. Your definition are too many things to memorize. I throw away. Calculation, I couldn't remember the formulas. I throw away. Then theory, explanations need to memorize keyword. I throw away. What is there for you to study? Right or not? That one is not called strategy. That one is called you being lazy. You just throw away literally everything. Might as well don't study, right? You can give out 1 or 2 because you got not enough time. But I'm not asking you to throw away every single thing. They are different there. You understand what I mean? So what happened here, right? You see, we start going now, everybody. Get ready, buck up. Now we start from chapter 1 first. I roughly go through, I let you know what is the idea here. So for chapter 1, frankly speaking, there's only 2 main parts I need you to remember. As in the 2 main things that they normally test in the exam. Number 1 is what? This one, base and derived quantity. And I suppose you remember this, right? Everybody, I suppose you remember what is base and derived, right? Still remember this thing? Now, base, right, is the mother of all quantity. It's like the ancestor, it's like, literally the parent of all other quantities. We got so many quantities, right? So those are considered as derived. So you just imagine this one is like the ancestor. And then, right, derived, you got infinity amount. You have thousands or millions of them. Every one of them, as long as they come from base, we call them as derived. So of course, base, right, is limited because why? It's the parent. So how many base we have left? Total of 7. Yeah, so the only thing I need you to remember is actually the base. Yeah, because why? For derived, right, there's so many, there's only memorized one. That's why you see in your textbook, in your reference book, right, you go and memorize them because they give you a table, all of them derived, and then you think it's important. No, it's not. That's why they can literally test you everything. So how are you supposed to memorize all the derived? Waste of time, right? But the point is what? Remember the base, and then when it comes to derived, right, you just remember this way. If you don't recognize them from base, that means they come from derived. You get it? Now, so what are the 7 base we have here? These are the 7 important base we have. We got the length. Oh, by the way, could you add on here for me? I type one word letter. Okay, one word lesser here. Length, the symbol is L. You can put a lowercase L or just you make it this way lah. Same thing. Either one also can. You can put L and then this one, but must be lowercase. Yes, I understand you guys have this bad habit, you know. You like to put any alphabets yourself. The uppercase and lowercase, right? Different meaning one. Yes, so like in chemistry also, when you're writing those chemical chemical symbol, whatever thing, you cannot look at one, you know. Exactly. Now, one of the best example, look at this. Time, temperature. See that? You see, time, right, is lowercase t. Temperature, right, is capital T. They mean different thing, you know. So you cannot say, could I say T equals to 10 seconds, and then T equals to 10 degrees Celsius? This is wrong. The small t stands for time. The lowercase one stands for time. The uppercase one stands for temperature. So that's why, right, the uppercase, lowercase cannot, you happy, you put whatever one. You need to follow. Exactly. So for length, right, lowercase L. And I suppose you know what is this, right? This is the unit for length. Okay. Then of course, typical, we have mass, we got time, we got absolute temperature, we got electric current, we got luminous intensity, and then also we have amount of substance. Okay, we got 7 of them. Now, what I need you to remember, 2 things in it. Number 1, I need you to remember the base quantity, the symbol. The symbol. Now, what means by symbol? As in, like, you know, in exam, you don't write temperature too long. Absolute temperature, electric current. So instead, right, what they do, they simply just put T to represent temperature, I to represent current. So I need you to remember the symbol because we use it a lot. And sometimes they literally just put, like, you know, M equals to 10 kg. So you need to know what does M stands for. Yep. Now, second thing I need you to remember, of course, it will be the unit for them. All right, kg, meter, seconds, Kelvin, ampere, candela, mole. Now, first thing first, do you notice, right, what kind of unit is this? You see, we have many units, isn't it? Like, let's say we talk about length. Beside meter, what else do we have? We have like cm, we have like km, we have a lot, right? So when we use meter, you look at these units, meter, kg, seconds, Kelvin, ampere. Now, these are considered what kind of units? This is a standard unit. You know, we all share together one. Everybody, whatever country, also do this. What's that? What's this? Exactly. This is what we know as the SI unit. This is what we know as the SI unit. Okay. So now, one thing, you probably ask, must I do SI unit every single time? I'm telling you one thing. SI unit, right? It's like a insurance for you. It's like a safety precaution for you. All right. Now, because in exam, right, they will give you different units. They give you cm, they give you km, they give you mm, they give you whatever. Now, you want to prevent any errors, you stick to one thing. You always, especially when doing calculations, when you're doing all the formulas, whatever, you always use SI unit. Now, one thing less to worry less, because why? Whenever you put SI unit, right, then whatever come out, let's say you calculate, for example, velocity equals to displacement over time. Now, if you were to put this, if you were to put SI unit for this and this, then whatever you found the velocity, it will also be SI unit. Then you don't have to worry, because some of you will get stuck here. You say, what am I supposed to use? Am I supposed to do like, you know, km per hour, or am I supposed to do meter per second? Now, simple. If you put SI unit, whatever come out, also SI unit. You get it? So whatever we highlight here, these are the SI unit for your base quantity. Meter, kg, seconds, Kelvin, ampere, candela, and then mole. Are you with me? Following, right? See, okay, can. So next time, if they give you anything else, right, but they give you grams, change to kg. They give you km, change the meter. They give you cm, change the meter. And then they give you hours, you change to seconds. We don't want hours, we don't want minutes, we prefer seconds, because seconds is SI unit. Understand? Can. All good. So here's one thing. Speaking of this SI unit thing, right? Sometimes, right, you see, what else they need you to know, you know. Here, number 1 is you need to be able to differentiate what is base and then what is derived. And a simple, there is only 7 base. So the rest of them are all derived. If you don't see them coming from base, right, that means the quantity, it's actually a derived quantity. Now, second thing, as I said, I need you to remember the symbol and units. Why is that so? Because, right, I need you to be able to form unit yourself. Because you go and memorize a waste of time one. How many things you need to memorize? Fair or not? Because so many derived again, right? So what happens is that sometimes, right, they will ask you like some random unknown terms. They ask you what is the unit for that. And always try to form yourself. You get it? Now, there'll be two situations. Number one is they ask you terms that you already learned. Like for example, what is the unit? What is the unit for velocity? And then you have to form yourself. Okay. Now, do you remember the formulas first of all? Do you recall formula for velocity or not? What is the formula for velocity? Velocity. Hey, velocity is not speed. Different, you know. Yes, if you're gonna tell me distance over time, that one is speed. Different. Okay, speed is distance over time, correct. But I want velocity. So what is a better word to use? Yes, you by right, you should use displacement. Yeah, exactly. It should be S over T, displacement over time, and only be considered as velocity. You get it? And then you see, do you know the unit for velocity or not? Now you say you don't know, never mind. What is the unit for S again? Displacement is actually length, isn't it? And that's why you recall this one, displacement as meter. Come, time taken. Look at it. What is the unit for time taken? SI unit. SI unit. Yes, seconds. So do you remember, right? Every time you divide, what happens? Every time you divide, what happens? You see, you take meter, divide by seconds, right? Meter divided by seconds. Now, divide are very simple one. Whatever on top, copy only. Whatever on top, same one. Basically, just copy, you get meter. So what you do is the bottom part. You shift this thing up. Now, every time divide means what? The bottom one, you need to bring it up. And then here's the thing, whatever below, right? When you bring it up, the power will reverse. Listen carefully what I say, the power terbalik. Now here, bottom here, this is S, which is power 1, right? So if you bring it up, right, the reverse means what? They become negative. Positive will become negative. Negative will actually turn back to become positive. You see that? Positive become negative, and then negative will become positive again. As in, if it's 1, bring up, it become negative 1. See that? Now, what if, right? What if, let's say, what if, okay? What if we have like this one? You don't care this one. I just tell you S squared. So if I bring it up, what do I get? If I bring it up, what do I get? I will get S minus 2. You see that? Exactly. So the power reverse. Now, what if I originally already negative 1? So what happens if I bring up S minus 1? If you bring it up, it will become MS. See that? Because 1 terbalik become negative. Negative terbalik become 1 again. Understood? Something like that. But of course, in this case, no lah, because velocity, right, simply just meter divided by seconds, right? So that's why the unit become meter per seconds. Now, this one, they ask you, what is the unit for velocity? You can try forming yourself. Now, this situation is the formula you know yourself, so they don't tell one. Now, there are cases where, right, they give you some random funny formulas, and then they ask you one of the unit inside. How you do that? For example, let's say, imagine I give you this, the formula to calculate whatever random formulas are. Okay, I give it this. Let's say now I have a formula. It's actually Q equals to MC beta. Have you seen this before? Have you seen this before? I suppose no, right? And probably it looks a bit crazy to you, right? Now, then you listen carefully, don't panic first. If they give you any formula that is not in your syllabus or not, you haven't learned yet, they will explain to you and they will let you know one by one. What does it mean by the Q? What does it mean by the M, C, and beta? Okay. Now, actually, this formula, right, is for us to calculate heat energy one. Q equals MC beta, right, is for us to calculate heat energy. Okay. So Q actually stands for heat energy. Okay. Q stands for heat energy. And then you smart guess, what does M stands for? As usual, typical one. What does M stand for? Standard, usual, eh? What is the symbol? M refers to? No. This one is symbol, not unit. This is symbol, not unit. So you cannot tell me it's length. The M there stands for mass, correct? Okay, mass. Now let's say I want you to calculate, sorry. I want you to derive unit for C. Okay, let's say you don't know about C. Never mind, you just need unit anyway. And then one more thing. Beta, right, stands for change in temperature. Okay, and that's all you have. Basically, I'm telling you everything already. Q is what, M is what, change in temperature is what, right? Now, first thing first, I want to find unit for C. What do? If I want if I want to find unit for velocity, I put velocity as subject. V equals what? So same thing, but if I want to find C1, I make C as my subject. I don't want Q equals something. I want C equals something. You understand what I mean? So based on this formula, you should tell me, right? Q equals MC theta, so C equals what? I got C equals what? This one your max. You only want C, so what do? Bring everything over, because multiply, if you bring to the other side, what do you get? Yeah, so it becomes Q divided by the M and theta. If you bring over, it becomes this. Got it? Then, right, now only you form units, one by one. What does Q stand for again? What is the meaning of Q? Heat energy, right? Now, questions now. What is the unit, SI unit we normally use for energy? You learned this before. Think about Form 2, think about Form 3, think about Form 1. I give you one hint. Any energy uses the same unit one. Heat, kinetic, gravitational potential, whatever energy. I notice you are still confused. Newton, right, is unit for what? Newton is unit for force. You know, some of you tell me weight is a type of force anyway. Then, is this like, can you say force is energy? Of course not, right? No. Newton is not. Energy, simple. What is the unit for energy? Yes, the unit for energy is actually J for joules. Yes, J for joules. Okay, one thing, J for joules. Now, one more time. What about the other one? And what about this one? The unit for M? Standard, right? I already told you what. M stands for mass, kg, right? Then theta, how? Now, you catch the keyword here enough, change in temperature. So what is the unit we use for temperature? What's the unit we use? Now, usually, right, we use degrees Celsius or Kelvin one. Usually, okay, we use degrees Celsius or Kelvin. But let's say now I want SI unit. What is the unit we use for temperature? SI unit. Yes. Now, could be degrees Celsius as well. But if they insist, I want SI unit, then you put SI unit. The temperature SI unit is what? Exactly, K for Kelvin. So what is the unit finally for C? Now, whatever on top, don't worry, copy only. No changes one. So the joule I keep. The only thing I need to do is what? Now I need to shift the kg up. Now I need to shift the k up. So if you shift the kg up, what does it become? The kg go up, become what? Yes, kg go up, become kg minus 1. And then Kelvin go up, become what? K go up. Yes. So finally, right, what happened? You will get something that looks like this. And yes, they are like that one. They are very funny. They are very weird. Memang lah, in exam when they test you, they give you this calculation. So you doubt yourself. You look at the answer, you feel like, am I correct? But it sounds like, it looks a bit weird, but never mind. That's the idea. So you see, I don't need to memorize derive, because why? You can always form yourself. All right. If they give you something that you never learned before, they confirm give you the formula and then they explain to you. If they're asking you things that you learned before, then of course you need to know yourself. You need to remember the velocity formula, you need to remember the acceleration formula. Those are the things they ask you. But to be quite honest with you, if your exam is only until chapter 2, like some of you 2.1, some of you 2.2, right? To be quite honest with you, yes, we got 7 days here, but if you talk about chapter 2 only, then you practically just need this. Yes, only the first 3. You will use it because why? Length is distance. Right? All your height, all your diameter, all your displacement, they are all considered as length. So you need this, unit meter, and then mass typical, mass multiplied by whatever thing, kg. And then time is for velocity for accelerations. Absolute temperature, you only start using it in Form 4, Chapter 4. So I don't think anyone goes too crazy, right? Until Chapter 4 for your first time exam. I suppose not, right? Electric current, you learn in Form 5, Chapter 3. So very low chances, unless they ask you like specifically chapter 1 questions. Then for example, they could ask you this one, then temperature is, I'm not saying that you only remember these 3, or you go through, just that the first 3 is more useful, more often used. You get it? Luminous intensity, to be quite honest with you, none of the chapter teach you how to calculate this. You just need to know that this thing exists, that's all. And then this one, amount of substance is more like chemistry, isn't it? The number of mole thing. Yeah, so physics also, we don't really do much. That's why, to be quite honest with you, in your physics syllabus, from 4, from 5 together, only the first 5 are important. You will actually use it one. These 2 is just for you to know. because got 7. Okay. Now you see the difference, right, between base and derived. So 7 base, please remember them, and then anytime derived, right, use the way I show you. Okay, use the way I show you. Any questions you can ask, right? If you have no questions, if you have questions, you can ask me now. Right? There's nothing to worry about. Yeah. Okay. Can we go on now? With me. I need to make sure you're all okay before I go on. I don't want you all like lost and then all the way lost. What's the point, right? So you got problem, ask. Okay, don't hesitate. Okay. And also one thing, regarding unit, some of you ask, hey, can I K minus 1 J G minus 1 there? Normally we want to make sure the unit looks a bit neat, looks arranged. So that's why normally what happens is we put the power smaller one high, we put the power bigger one in front. So you say, can I do like that? Actually, can, but normally nobody do that one. Because based on the formula, it will be joules per kg per Kelvin. So kg first, only Kelvin. Can change in temperature. No. You don't put it, you don't combine with your max. Yes, this one stands for theta. Like literally the angle theta, but theta here stands for change in temperature. Different meaning one. Because I know you learn this symbol in maths also, man. Same symbol, but then different meaning for physics. Okay. Can we go on? Come on. This one is the angle theta, correct? But then here the theta stands for change in temperature. Now next thing also, I told you how to practically we are going through the checklist already. You notice that? So you say, hey, this one base, okay, I'm clear already. I remember all 7. Then you put a tick for yourself. So I'm checking through the checklist for you. And then you got any problem, you want to find out more, go and study also. Right? Able to form derived quantities from base. There you go. You did that, right? You're able to do this, then you go on already. But that's the point of having a checklist. And then somehow able to state the difference between scalar and vector. Now, here's one thing. When it comes to this, do you recall what is scalar and vector or not? What is the difference between them? I suppose we only have one difference, isn't it? How do we differentiate between scalar and vector? How do we differentiate between scalar and vector? What is it? There's only one difference, actually. Yes, scalar and vector, there is only one difference, which is what? Scalar has scalar has no directions. Okay, now scalar does not have any directions. And then, right, vector got directions. That's it. Okay, scalar got no directions, vector got directions. That's the only difference. Now, some of you did mention about the word magnitude, right? Because the actual definition for scalar is quantity with magnitude only, and then vector is quantity with both magnitude and directions. Do you know what does it mean by the magnitude? Do you know what does it mean by the word magnitude? Simple. Magnitude means value. Yeah. So the word sounds very scary, but it's very simple meaning. Like for example, if I ask you what is your mass, you're gonna tell me you're 40 kg, right? The number 40 stands for magnitude. Yes. And you see how to differentiate between scalar and vector. Actually, very easy one. You just think about it properly. Do that thing need directions or not? Then that one is the answer already. One example, let's say we talk about mass. Do you need direction for mass? Do we need direction for mass? Like when I ask you, how heavy are you? What is your mass? Then you tell me what? If I say, what is your mass? What do you tell me? You tell me you are 40 kg. You tell me 50 kg. Then the question comes, do you need the directions? Like, do you hear people telling you, oh, I'm 50 kg going down. Then he is 40 kg going up. Hey, hello. When people mass go up, you go up, what happened? You start flying already, you know this or not? You start floating, isn't it? Now everybody go down one. I mean, that means you don't need that. You see the point now? So if you need direction, then it is a vector. If you don't need directions, that's a scalar. Now, a few more. Now, actually, for scalar and vector, right? One of the things that the most frequently asked questions about scalar vector, it's actually your chapter 2. Do you remember speed and velocity? Do you recall speed and velocity? Now, they practically mean the same thing, Speed and velocity is telling you how fast you're going. Right now, speed, how fast you're going. Velocity, how fast you're going. The only difference is what? Speed is a scalar. And then velocity is the vector version of speed. Velocity is telling you where are you going exactly. Now, are we going forward? Are we going backwards? Okay, so velocity is a vector, and then speed is a scalar. See that? Then we try a few more. Then you tell me answer. For example, force. Force is a scalar or vector. Smart guess. Force got directions or not? Force got directions or not? Think. Force got directions or not? Now, you see, let's say this object, I push here and I push here. Do they go the same way? They go differently, am I right? If I push here, of course they go here. If I push here, they go here. Am I right? So how do you need to show them? Like, how do you supposed to tell the person, I am pushing the box, the object where? You need to show direction. So force is a vector, correct? Force is a vector. See that? And then speaking of this, see, we keep saying vector, vector, vector. How do we tell direction actually? Like, let's say, for example, you say velocity is vector. Then how do I tell someone I am going velocity forward or backward? How am I supposed to know? Now, one thing for you, when we talk about direction, I suppose the first thing come across your mind, you think about all the north, east, south, west thing, right? Because the geography, north, east, south, west, up. For physics, normally, you only need to deal with one dimensions. Now, what is the meaning of one dimensions? As in like that, left, right, or up, down. You normally just have to differentiate one plane. So that means what? You practically just need to differentiate what? Two directions, am I right? Left, right, or up, down. Make sense? Questions? How do we do that? You know this one, you think about it. How do you do that? We use positive and negative, exactly. Now, here's one thing, a lot of you be scared about this positive negative thing. You see, the positive and negative, right? The main thing is negative, actually. Yes, so the idea is, we don't really care, like, do we have a fixed answer? Must I go left negative, go right positive? No such thing. It depends on what? It depends on the idea. The negative, it's opposite. So if you are going left, then when I put negative means what? Going opposite right. So can I do left positive? Can. Then right negative? No. Can I do left negative? Then can. Right become positive. As long as right on the other side, we put a negative for it. Like same thing. Must I go up positive? No such thing. One. Up can be positive. Up can be negative. Up positive, then down negative. Up is negative and down is positive. As long as right, you want to show two-way positive, negative, negative, positive. You understand? So for vector, right, how do we tell direction? Simple. We put positive and negative. So next time, right, you pay attention. Next time, right, whenever we trying to show, whenever you calculate anything, you got answers, you calculate everything. If you get negative answers, right, that doesn't mean very, very small. Because I know that you learn in maths, negative means the value very small. No, for physics, right, negative only mean one thing. They are trying to show you are going in opposite directions. See that? So this is when they need you to be able to give examples of scalar and vector. Right? I mean, I think we did just now, right? What are the example considered scalar? Just now we got mentioned, right? Speed, right? Then the vector version is what? The vector version punya speed, what do we call that? Yes, that will be velocity, right? Now, what else can we say? This one is like a twin brother. Got one more also, a bit like twin brother one. Yes. Now, distance is scalar. So the vector version is called what? Distance is scalar, the vector versions, the upgrade. No, distance. Exactly. Then of course we got something called displacement. There we go. We got something called displacement, right? You see, isn't that the same thing? Both also showing you how far you're going, right? Just that what happened? This thing actually tells you directions, and then this one just sum everything together. And then one thing also very important, displacement a bit special is what? Whenever you try to measure displacement, they only measure the shortest distance between your starting and ending. So they don't care how many times or how many turns you make one. Let's say, for example, if I start from here, I go straight, and after that I go down, and then I turn again, and then I go up again, like that. Now, if you were to calculate distance, you take this one, sum this one, sum this one, sum this one. Okay, 1, 2, 3, 4, everything sum together. That's called distance. But if you're gonna calculate displacement, you know what you do or not? Starting point ending point, you simply draw one straight line all the way. That basically is what we known as displacement. Okay. Now, symbol is important because why? You're confused all the time. Velocity symbol is what? What's the symbol for velocity? Yes, that be velocity is velocity symbol is what? That be v, right? No, I'm not asking for unit. I want symbol. Yes. Displacement. What is the unit for displacement? S, correct. Okay. Now, what's the symbol for speed? Also S. And then distance is? Now, this is one thing you need to understand. Alphabet, we are limited. That's why sometimes, right, there will be cases where they repeat. So this is when you start to confuse. Say, hey, then how am I supposed to know? Like the S actually refers to speed or displacement. That's why you need to differentiate the scalar and vector. So when you calculating scalar, speed equals to what? Distance over time. You put the scalar. Whenever you calculating velocity, then you put vector version, which is displacement over time. You see that? So that's why you see when you're calculating vector velocity, then you know this one not going to be the scalar side. It will be the vector side. That's why the S refer to the displacement. See that? So that's why you know the S here refer to displacement, not speed. Understand? Because scalar, vector will be separate. We are good. I'll ask you one more. Time, scalar or vector? Time is a scalar or vector? Then you start thinking, time got directions or not? Correct. Time, of course, it's actually scalar, right? Time is definitely scalar. Well, some people say, hey, but then time I thought got directions on, we can go back, go in front. You think properly again. Do you actually go backwards? I mean, of course, we wish that, that will happen. I wish that we can go back in time, but will time go backwards or not? No, time keep going forward. Exactly. So there's no direction you could tell because time just keep going on. That's why time is also considered as a scalar. Got it? So that's how you differentiate them between the scalar, the vector thing, how you form unit for yourself, and then the differentiations, how do you tell directions? We do positive and negative. We do plus, minus. Negative is to show directions, opposite directions. Understand? So far so good, everybody? Can. I know you learn, you've gone through chemistry just now, but I suppose you still got brain power now, right? You learn chemistry first, you learn physics first, then you feel like dying faster, Yeah, for those Mandarin class they do physics first, then only they do chemistry. That one even harder for them. Yeah. But how was chemistry just now? Chemistry got a lot of calculation, man, just now. Your beginning part. Got good. Physics also got a lot of calculations. How come? You focus on calculations. Good thing also because your exam coming also there's supposed to be all calculations. All right, can we go on someone? And try not to squeeze your brain too much. But of course, things that you need to know for exam, I make sure you know also. Now, after this, then of course the second part for chapter 1, the important thing is what? You have the scientific investigations. This thing sounds like very, very serious, but more like idea is what? It's more towards this thing. The idea of scientific investigation, simple as this, it means graph. Okay. Now, I suppose you all done experiment before already. At least one experiment. Have you done one lab session in school? The pendulum experiment, the ticker tape experiment, I suppose you did. Just at least one, right? Now you see, when you do experiment, right, you need to collect data, right? You need to collect the results. Then there will be table. Of course, they ask you to draw graphs. Now, chances they ask you draw graph this time actually quite low one. Especially you see, if your paper is combined paper. Actually, for physics, we have 3 paper, The actual format in SPM, you got paper 1, paper 2, paper 3. That one then guarantee got graph because paper 3 is experiment. Then they will ask you draw graph. But for first time exam, most of the time, most of the school, right, they get combined paper. As in, like, you only got one paper, inside got objective, inside got structures. So that one, they ask you to do graph, then lower chance. But of course, you must know also, in case not right. But one thing for you, a good news for you, anyway, you see, regarding graph, right? Let me tell you what. the graph they ask you to draw, okay, the graph they ask you to draw, the graph they actually ask you to draw or calculate, it must be a straight line graph. Okay, now you know what does it mean by straight line graph or not? That means you will basically be having linear graph. Because I know you'll be worried, say, hey, what if I go crazy? You know, do we get graph like that? Do I get graph like that? And then ask me calculate, do I get graph like this? Don't worry, that one not a problem. Okay, that one not a problem. Basically, right, for this linear thing, okay, your graph, let me ask you a question. If you draw a graph and the graph must be a straight line, how many combinations could you have? What are the possibilities you could have when we drawing the graphs? Smart guess. Now, let's say this is your graph. Let's say this is your graph. Then how? You can do like this. 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 You only got a few answers, isn't it? And now, literally, I gave you the answer already, you know. Literally here, they ask you to describe the shape. And all the answers are already listed here for you. You have a few things. You get directly proportional, you get increases linearly, you get decreases linearly, and you get inversely proportional. Okay. Now, first thing first, do you understand the meaning of every single word there? First thing, directly proportional. Now, what is the meaning of directly proportional? And I say this graph is directly proportional. What does it mean? Now, of course, your graph, you're gonna have like, you know, y-axis, x-axis, right? You're gonna have y-axis, x-axis, right? When I say directly proportional, what is the relationship between x and y? Questions, must I equal? Must it be equal? Not exactly. Exactly. Not exactly. Because why? Now, when we say directly proportional, of course, when y equals to x, consider as directly proportional. When y equals to 2x, also can say directly proportional one. So must I equal to x? Not necessarily, but the idea is like that. See, for directly proportional, right? Simple. When your x increase, your y increase together. That means directly proportional. It means they go up and down together one, like they together. So same thing, when your x decrease, right? Let's say here, if I have x dropping, then the y also dropping. You understand? So this is the concept of directly proportional. Now, I mean the word you can kind of relate that direct means they do the same thing. They go x go up, y go up, x go down, y go down. You understand? Now, then if you got directly proportional, you look down here. Here we got something called inversely proportional, right? Now, smart guess, what does it mean by inversely proportional? A bit similar, right? The name directly proportional, inversely proportional. Direct means up, up, down, down. Smart guess, what means by inverse? Now, what is the meaning of inverse? What is the meaning of inverse? Inverse means reverse. It means the balik. So that means now if I ask you, when x and y, when my x go up, what happened to y? When my x go up, what happened to y? X increase. Y will? Y will? Yes, it drops, it decreases. You see that? One more time. What if right now, what if I ask you when x increase? Sorry, what x decrease? What happened to y? Obviously, then this is when you go up. See that? So simple. Up, up, down, down. Up, down, down, up. Then of course, what is this increases linearly? A bit similar also. Later I explain to you. This one I roughly estimate only. I mean, like I give you a summary only. You bear this in mind. This is not the full notes. I got detailed notes underneath one. Because I know you need to study anyway. So this is all the notes I can give it to you. And after that, right, the idea is these are a short one so that you can check through. Every time you go through. Oh, this one okay already. I gone through. I can put a tick there. I gone through. I put a tick there. So ultimately, right, your checklist will be full of ticks. And by the time your checklist is full of ticks, then you know you are ready for exam for these chapters. So this thing, right, number one, for those who actually haven't started studying yet, it's a very good checklist for you. You can refer to this. Now, second thing, for those who actually started studying already, and then also it helps you to at least know what did you miss out or did you miss out anything. Because I know, I mean, I suppose you guys have this constant worry. Like you study already, but then you don't know whether you finish or not. You don't know whether you study finish it. I know your biggest fear is what? You know, let's say half an hour or 15 minutes before exam, your friend come to you with questions and ask you how to do. Then the moment you look at the questions, right, never seen before. Then two of you get panicked there. Oh, what the hell is this? Now, let me tell you one thing, okay? Number one, half an hour, 1 hour before exam, don't talk to anyone. Yes. You see, let's say the question really come up. You really don't know how to do. How many marks are you going to lose? 3, 5? But the moment you panic, you're losing more, you understand? Because when you panic, you start forgetting even more. And the problem is what? You are losing 30, 20 marks already. And then how is it worth it, right or not? Just let it go. All right. So 5 minutes, 30 minutes before exam, right? Don't talk to anybody. If you see someone, right, holding a paper coming towards you, you just, no, don't. I don't know. I very dumb one. Go to him. He's smart. He's number one in the class, not me. Go away. Settle. Don't talk to anyone. Okay. Now, if really this happened now, okay, you say, but this one best friend, I cannot ignore him. And then how? Now, if really your friend come to you with the questions that you totally don't know how to do one, how? By then, half an hour before exam starts. Teach you one simple way, also very easy one. You take up your right hand and then put on your left chest, and you do like this, and you tell yourself, "Aya, won't come out one." Then you move on. I mean, at that point, what can you do, right? Half an hour, and then so that's it. I mean, as I said, okay. As I said, come out then how? Come out then 5 marks gone only, ma. But when you panic, you're losing even more. Now, that's why the checklist to prevent this from happening. To prevent this from happening. That's why, right? I give you this checklist, so you're not gonna have that situation happening. That's why I list down this for you. You check through. That's why important one. Okay, you sure this one you study already? You put a tick. It's like, you go for traveling. You want to pack your luggage. How do you prevent not missing out anything? Checklist. Same thing. Okay, so go through this, check through them. Okay, do I know about all this? Do I remember all these 4 answers? If I do, I go on. Then somehow I put small boxes, So you go through each of them one by one. If you're okay, then move on. The next one, you need to know how to calculate gradient. Now, do you recall how do we calculate gradient? Actually, gradient very important because not just only chapter 1, and you go to motion graph, I suppose they ask you to calculate gradient also, isn't it? Yes. So what is the formula for gradient? Come. What's the formula for gradient? Gradient formula is what? Y2 minus Y1 over X2 minus X1. Now I notice you guys got one problem here. You are lazy about writing formulas, man. You see, of course, the formula you don't write, they don't minus mark one. But the problem is what? Sometimes you think you okay. You say, never mind, eyeball. I use my eyeball, and I see that, and then you miss out the marks. Then the one careless, isn't it? More concerned because why? You know how to do, you know exactly how to calculate. Just because your eye separated a bit, your eye like sagged a bit. Then make it a good habit. Always start from a formula, and then you label, you accordingly choose. When you practice more already, you are confident. Okay lah, I don't need to rely on this formula anymore. You can skip to the number straight away, but make it a good habit. Start from formula and then something to refer to. And you see, you know why the Y2, Y1, right? Because you got 2 points, right? Label the coordinates of the point, so you won't make careless mistake. So Y2 you go to point 2, Y1 you go to point 1. Then you got no problem. See that? The gradient later I show you how to calculate, because I know confirm got problem later. Okay. So this is the idea when you go through chapter 1, you check through. But one thing, students, everybody, be honest to yourself. Okay, you only take it, you only check it if, only if you know exactly what is happening. Okay, you don't take for the sake of taking. The night before exam, I got not enough time to study. How? Then you go and take every one of them. See, put tape like that to make yourself feel better. And then right? How is it gonna work? Just because you take like that and then magically the knowledge appear in your mind? This is not some magical charm, I mean, if I do this way, right, I'm not a teacher, I'm a bomo, Exactly. So read through. And now, one more thing before I go to questions, this one, right, is additional part. Because right, if your exam only got chapter 1, 2.1, because some of the students telling me that their school only got 2.1. You see, with such little thing tested, right, then chances are they like to test a bit of Form 3. So this one, right, is insurance for you. Now let's hope that it won't come out. And in case These are the things you need to know a bit. In case they decided to surprise you, never mind, you still okay. All right, now the two things you need to know. Number one is the measuring instruments. Number two is the prefixes. Now, speaking of measuring instruments, right, simple. You need to know how to take reading using instruments, and then also you need to determine zero errors. All these things I put inside for you, and then somehow I got short notes for you inside one, so you can roughly go through a bit also. Yep, the parts are the function, everything. In case you need it. So this is like insurance for you in case they are tested. But let's say your teacher tell you, your school teacher says, confirm no form 3, confirm no P3, and then you can ignore. So this is the additional. It depends on school. It depends on whether your teacher says got form 3 stuff coming out or not. And speaking of measuring instruments, right? To be quite honest, actually these are quite logical to ask one. Like, you know why? Because you need to take graph. Sometimes you have to take measurement, right? But then you involve instrument, isn't it? So the important one is this three: vernier caliper, micrometer, screw gauge, and triple beam balance. You make sure you know how to take reading at least. Zero error, you say, I'm not so sure. Okay, one, but make sure you know at least how to take readings. Yes. So this one I got time I show you but since additional, not everybody coming out, so I put it in just in case you need. Okay, extra thing for you. Now, do you recall prefix? You need to know the value for prefix because you know why not? Normally prefix they will come out in objective. They will ask they give you 4 options A, B, C, D. 50 nanometer, 60 terameter, 70 gigameter, and then 80 micrometer. Then they ask you to choose which value is the smallest, which value is the biggest. So you need to know. Now, prefix are those alphabets, the tera, giga, mega, kilo thing. Then you need to know what does nano means, what does tera means, what does giga means, what does micro mean. And then you have to choose the smallest one. Answer is A anyway, nano. Because nano is 10 to the power of -9. Micro is 10 to the power of -6. Tera is 10 to the power of 12. Giga is 10 to the power of 9. Do you remember this? I think you learned this like what in Form 1, I suppose. Yes or yes? How many prefixes do you have learned actually? You know how many prefixes you have learned? Form 3, chapter 2 also got. Is it? Now in total you learn 12, correct? And again, of course, I don't expect you to remember one. There you go. I prepare for you already. Okay, there you go. I prepare for you already. You see, tera, giga, mega, kilo, hectare, deca, decimal, milli, micro, nano, pico. In total, we got 12. I mean, for physics, of course, there are more. But for physics, right, I only need you to know this 12. Yep. So tera is 10 to the power of 12, means 1, and then you got 12, 0 behind. And then 10 to the power of 9, 10 to the power of 6, 10 to the power of 3, 10 to the power of 2, 10 to the power of 1, then -1, -2, -3, -6, -9, -12. How to remember them? Of course, you ask, right? Now, number one, that would depend on your calculator. Are you using the 570 ms? As in the gray color one, the very OG version, the old style one. Yes or no? Never mind, I'll show you photo. Let me show you photos. Are you using this? Are you using this? If you're using this now, see 570 ms. If yes, right, then good news for you. Why? Now you look you look here. You see all the number above. You see there's letter there. And that's your prefix. Tera, giga, mega, kilo, milli, micro, nano, pico. So they ask you for nano, you press shift 3. Then nano come up. They want tera, then shift T. Of course, you put number in front. T don't stand for anything. You must press like 10T, 2T, 1T like that. Exactly. So if you're using this calculator, then good news for you. There we go. You don't have to memorize all these things. Now, are you using the 570 ES? Are you using this? Now this one, then bad news. Why don't have? They took it away. I don't know why. They don't have it anymore. So that means you have to remember. Never mind the one I settle you later. Are you using 570 EX? The latest version, the very atas one. The very chunky one, can draw table one. This one. Now, you press option and then you choose 3, supposed to be inside already one. Aha. So only the silver color one don't have. Never mind, I got you covered, relax, okay, I know what's happening one. Okay, now, what if, or maybe some of you say, I'm not even using Casio, I'm using different brand. Or I don't have scientific calculator, I'm using the kopitiam auntie used to calculate the copy money one. Okay, only got plus, minus, multiply, divide, how, right? Then you need to remember this value here. How to remember? Simple trick number 1. It's a coincidence anyway. How many prefix we have? How many prefix we have here? I just only mentioned one, right? How many prefix do we have here? You got 12, correct. And then just so happen the 12 prefix, and then the power start from 10 to the power of 12. Then you look at this value. Do you see a pattern there? You look at this value, do you see a pattern there? Now this is the idea when you study, right? How to study faster and smarter. Look for patterns, look for similarities, look for differences. You realize, right? Actually, here it's like a mirror. It flips the value down. Yes, so and then every time when you go start from 12, every time, what happens? You keep on -3 until you get to 3, and then 2, 1. Right, you see 12 -3, -3, -3, then 2, then 1. After that, right, mirror. What means by mirror? You see 12, 9, 6, 3, 2, 1, and 1, 2, 3, 6, 9, 12. So this is how you remember the value first. Okay, start from 12 and then -3 until you get to 3 already, right? Then 2, then 1. After that, flick 1, 2, 3, 6, 9, 12. Value settle. I remember the patterns already. Then the problem is what you have to match with this also, right? I know 10 to the power of 12, but I don't know it refers to which prefix also cannot what, right or not? So you need to know how these things. You need to know exactly the sequence also. Tera, giga, mega, kilo, hectare, deca, deci, centi, milli, micron, pico. How we do that? You just remember one sentence enough. This sentence, right, settle everything for you. Okay. Now what does it mean now? Look here. You just remember this sentence. Tomorrow, go Mid Valley. You all come from I mean we don't have any outer state students, right? Then I suppose you should know where Mid Valley are. Okay. Kiss, hippo, daddy's something can meet. Now this one, right, it's actually a Greek word. This one, right, is actually a Greek word. You know what's the meaning of Greek word, right? I know the alpha, beta, gamma thing. This one, right, actually pronounced as mu. It's actually M, but it looks a bit like a U, right? So you can see it as U also, like a U and then with a tiny tail. Yes, so this one, unicorn with no E. Now, this sentence, we come back. Look here, look here. Later you copy, I let you copy. Okay. Tomorrow, go Mid Valley, case hippo, that is what can meet unicorn with no what. Now, here, what do we put here? Hippo, that is. Give me a body part. Start with D. You need a hint? The next letter is I, correct? Correct. Answer is dimple. Those who think all the bukan, you know lah, right? It's a test for you, okay? And of course, it's your book, right? You want to write anything also can. It's your book, right? Not exactly. Yes, put whatever you want. But if just say your parent likes to, look at your notes, look at your book, I recommend putting dimple is more safe now. Okay. Yes. If not, you're gonna have problem explaining to them. Can meet unicorn with no what? Okay, body part start with P. 5 letters. Correct. Pinky. You know Pinky, right? This one. Okay. There you go. So once you remember, every time, right? As I said, the patterns you recall, right? 10 to the power starting from 12 minus. And after that, right? you look at you just remember the sentence. Tomorrow go meet Valley. So while you remembering the sentence, right, you write down tomorrow go meet Valley, cheese, hippo, Valley, hippo, and eat unicorn with no D. Everything come out idea? There you go. So this one, right, a quick way to remember your prefix. Okay. Now, of course, you want to write down quickly, so I can go on some more. Okay. All right, next. Now regarding the graph part, I need to make sure you know how to answer all of them, because chapter 1, probably you get a bit loose already, because you tend to forget things real quick. Okay. Could you turn to page number 8? Page number 8. Page number 8. Now here we go. This one is all the linear graph. Okay, this is all your linear graph stuffs. And now, as I said, linear graph means what? Linear, it's basically straight line, right? And of course, there's only multiple ways you can draw straight lines, isn't it? You can draw like this, 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 you can draw like this. That's it, right? Must be a straight line, isn't it? Now, I know what you're thinking. Some of you will ask, hey, why don't have this? Can I draw a graph like that? Later I tell you why. Okay, later I tell you why. Okay, now one by one. First thing first, if I have graph that looks like this, sometimes they give you the graph, or sometimes they ask you to draw the graph, and then they ask for relationship. Now, what kind of relationship is this? What kind of graph is this? Now, simple. The key point here is you catch on this thing, right? If your graph starts exactly at origin, like exactly here, this is what I've been saying, I know lah. Starting from here, literally 0, 0, 1, and then they go up straight all the way. What do you call that? If you go up straight 0. Now, this one is the most frequently asked questions every time they ask one. Okay. Now, listen up. If you start exactly at 0, means when your x is 0, your y also 0. And when your x increase, your y also increase 1. Then the answer here would be directly proportional. Correct. It will be directly proportional. Yep. Cannot be increasing linearly. Later I tell you why. Okay. Here, if you start exactly at 0, then we call them as directly proportional. Yep. The keyword, I mean, you can only say directly proportional if and only if your graph starts exactly here. No other places must be starting at 0, 0 as an origin. Yep. Now, of course, question comes, what if I don't start from 0, 0? What if I don't start from origin? Like, for example, what if here, my x is 0, but then my y is not 0? How? Now, this one also, this one, right, they go up straight. Now, whenever you see graph going up, increasing in a straight line, and the answer will be increases linearly. This one, then yes, increases linearly. So these two graph is the most famous two, and then every time before exam, I'm sure got many people ask one. Yes, a lot of people asking one. So how to differentiate them? Simple. You recognize this one. Every time you will hear your friend asking you, hey, how start from 0 is what? And then if you don't start from 0 is what? Simple. If you start exactly at origin, then directly proportional. So if you're not just going up and then straight, they are not, I mean, they look very similar, isn't it? The only difference is what? The only difference is that this one don't start from origin. And this one, right, it's called increases linearly. Understood? Can. Okay. Any questions about? Can we go on, someone? Good. Next. Now, you see, the graph go up straight. It's called increases linearly because they go up, because they straight line. Smart guess. This one, if the graph go down, straight. Go up is increase, go down, decrease, and then straight line. Go down and then straight line. Smart guess. Exactly. Then of course now it becomes decreases linearly. Decreases. Okay. But you look at the answer fully. Actually, right, the full answer is what? When we say y, right, it should be y decreases linearly as x increase. Because why? Yes, your y is dropping, but your x is continuing going up, isn't it? You see, as you look at the graph this way, your y drop, correct, but your x keep going. Realize that? So decreases nearly as x increase. Get it? Now, number 4, very easy. That's why I don't even bother asking you to answer. Number 4 is literally just y is constant. Why? Because the graph straight line, not changing. Of course, y is constant, right? Now, then this is when I ask you a question. You know, when you draw a graph, when you have experiment, when you're doing a graph, normally, right, for the y-axis, right, what do you put? Normally you got two variables now, right? You got manipulated variables, you got responding variables, right? Normally, right, for y-axis, do you put responding variables or do you put manipulated variables? Y-axis, as in this one. Exactly. Now, I'm not saying all the time. Normally, they put responding variables here, and then for x, right, it's manipulated variables. So your graph can be like this. This one means what? This one means, right, as long as I keep, no matter how I change the manipulated, I still get the same responding. Means I don't have any change in result, right? But can I have graph that looks like this? Can I have, is it possible to have graph that's straight up or not? Now, what does it mean if your graph like that? That means, right, one manipulated, I get many responding. That one is your experiment going crazy already. Imagine you do one time. First time you do, let's say, imagine your manipulated variables, it's the mass of the object, it's the mass of the chemical, whatever. First time you put 1 gram, one result, and then put 1 gram again, another result, put 1 gram again, another result, put 1 gram again, another result. That one is your experiment going crazy already. So that's why, right, this is not possible to happen one. This one, yes, but this one, no. Can? So that's why no straight, just like that. Understand? Now, the most hard one, actually, the last one. To be quite honest, seldom they come out, but when they come out, right, we have to be extra careful. Look at number 5. Well, look at number 1 again. Look at number 5, and look at number 1. The shape look the same, isn't it? This one and this one, the shape look, I mean, not literally same, right? I say the shape. Same, right? But what is the difference? Look at the graphs. Could you tell me what is the difference between the first one and the fifth one? What is the difference between the first one and the fifth one? Yes, the only difference here you will notice is actually now for this graph, right, the x-axis, it's actually 1 over x instead of x. Before that, you see, right, we are normally doing y-x, right? Now this one, right, they will be y and then 1 over x. Meaning what? Like, once you got the once you got the x result, you 1 over the result, and you see. Let's say, for example, your x is 2. 1 over x is 1 over 2. Then you put 1 over 2 inside here. Exactly. Now, but why do I say important? Simple. Now, first thing, right, if you just look at the shape of the graph, okay, you don't care the 1 over x, whatever thing, you don't care the 1 over x, whatever thing, just look at the graph. If I, now imagine the 1 over x is like unknown. One value, you see it as one thing. Don't care about the 1 over whatever thing. Now, for example, you see it as a, okay? You see it as a. Now, based on the graph, if you look at the graph shape, can you tell me when my x increase, okay, when x increase, when a increase, what happened to y or not? Look at the graph. Look, when your a value increases, what happened to y value? Increase or decrease? Look at it. When my a increasing, the y actually increases together, isn't it? And literally, if you start exactly at 0, what relationship is this? Supposedly, start from 0, 1, start from origin 1. We call this as what? The directly proportional, right? So what I want to do, the a is actually what? It's actually the 1 over x. So if you see 1 over x as 1 person, you don't care the 1 over whatever. You just see this as one individual. 1 over x increase, y increase together, right? And then look at the graph. You tell me they are directly proportional, right? So whenever you're getting this graph, extra careful, because why? If they ask what is the relationship between y and 1 over x as in the whole thing 1, then your answer is actually called directly proportional. Yes, now look at this, y directly proportional to the whole thing 1 over x. Okay, but what about y and x only? I only want the one, I only want the x. How? Now look here. I put this aside. Could you tell me, right, when the 1 over x increase, what happened to value for x section? Increase or decrease? Now, never mind. This one we do a bit of maths. You can see, because some people say I cannot understand. I cannot understand. Now, never mind. You see, let's say if 1 over x is 1, do your maths. X equal how much? 1 divided by x equals to 1. So x equals to, hello, simple math. What is this? Yes, 1. Okay. Now, if 1 over x equals to 2, then x is how much? 1 over x equals to 2. Hey, hello, if you want x, what do? Bring the 1 over. Bring this whole cap over, right or not? Nah. Make sense? So actually, 1 over x equals to 2. Then obviously your x is actually equals to 1 over 2. You follow? Can follow? Okay, this is maths only. No crazy whatever theory behind. Okay. Now 1 over x equals to 3. X is how much? Shift the 1 over. Bring this cap over. Exactly. Then we get 1 over 3. Now you look at the number. My 1 over x value, 1 become 2, become 3. May I know what is happening to the value? Increasing or decreasing? You just look at this and tell me. 1, 2, 3. Increasing or decreasing? Increase, agree. Hey, no, this number. 1, 2, 3. Why got decrease? I don't get it. You know, increase one, right? Okay. Now then, you look at this number again. The value for x, 1 over 2, 1 over 3. Is it getting bigger or smaller? 1 and half and 1 over 3. Increase or decrease? So what is the conclusion here? We know that the relationship between 1 over x and x is like that one. When 1 over x gets bigger, your x are supposed to get smaller, right? And then just now we were saying, all right, based on the graph, when 1 over x gets bigger, actually y is getting bigger also, right or not? Now here's the thing. Look, all these I take away. Okay, I take away. So now you know that this one go up when your 1 over x go up. At the same time, when 1 over x go up, actually x will go down one, right? So when I put them together, these are the relationship you have. See that? Now, so for number 2, you are looking this one. Up and up. That's why proportional. For number 1, what they're asking now, what I want. I only need y and x, right? So I take away this and you tell me what kind of relationship is this? X down, y up. Just now we got mentioned before, right? The valid one. What is that? Yes, that is why, right? This graph is dangerous because why? You need to look at the question very, very carefully. Now, you don't worry. You say, hey, what if they never ask? What if they never mentions, right? Which one do I put inside? You put anything inside also correct. Because why? They will actually tell you what. They for sure ask very detailed one. They will ask you, what is the relationship between y and x? And what is the relationship between y and 1 over x? If they ask you y and 1 over x, answer this. If they ask you y and x only, answer this. Understood? Questions? And there you go. This is literally, I'm giving you the answers already. If they ask you about relationship, right? This is all the possible outcome we have. Straight line graph, that's all. All right, nothing else. Okay, everybody? If you're clear, send me a clear lah. All right, if you have a question, you can ask. Don't hesitate. Nothing wrong. Okay? Okay, very right here. Go on somewhere. Next, we calculate gradient. And then, by the way, when you don't understand, right, please explain why you don't. I mean, like, please tell me which part you don't understand. You don't just, I don't understand. Then at least you let me know why is it this part like that. Then how am I supposed to know which part you don't? I need more input from you, isn't it? Now look at these questions here. Number 1. Okay, question A, straight away, ask you calculate gradient. How you do that? They ask you calculate gradient. How you do that? Now, first thing first, we don't care lah. Remind the formula first. How do we calculate gradient again? How do we calculate gradient again? Formulas? Y2 minus Y1 over X2 minus X1. You know what is this Y2, Y1, X2, X1 thing, right? Yeah, exactly. Now, always make it a good habit, label your graph. And you look at this, your point are limited one. They do this all the time. You're not going to get an entire graph you can calculate anywhere you want. Like for example, do I know what is the value at this point? Do I know the coordinates for this, for this, for this? All right. You literally got 2 points only. Realize or not? What is the 2 points we have? Of course, number 1 point is here. 2 is, of course, the easy one, the origin. Origin here, of course, we know 0, 0, right? Now, what is the value here? The coordinates at this point. At this point. This is when you're getting. What do you get? 12. Hey, xy, not yx away. X, y. So 12, 7, not 7, 12. Don't mix up. Exactly. X, then y. Now, you got 2 points already, right? Substitute accordingly. Whichever as your point 1 also can, whichever as your point 2 also can. But your rule is what? If you're going to say this is your y2, then this must be x2. Follow. If you're going to say this one is your y2, can also. That be your x2. Then here you change it to be x1, x2. You understand? That's right, x1, y1. Yeah, so when you do this often, right, you can remember, you don't confuse yourself. Because I'm still seeing people getting a lot of weird numbers. Exactly. No. We see the number only. We don't care the 1 over q. Yes. What is the x coordinate? 12, then 12. Yes. You don't have to worry the q. The 1 over not important one. They put that for fun only. As in 1 over q is 12, correct. And then this one also, we are referring to 1 over q. Hello, we are not asking for q. Your x-axis is 1 over q. So just take the number. Okay. Then substitute the rest. I think this one quite easy. Right? Put inside. Y2 is 7 minus 0. Y2, x2 is 12. X2 is 12 minus 0. What do we get? 7 over 12. Decimal point. 7 over 12. What is the decimal point? Now, for physics, right, we always recommend you to do one thing. Always put them in decimal point. Do not leave your answer in fractions. Normally, you got 2 situations, you can leave them in fractions. Number 1, if they ask you a ratio. Number 2, if they ask you to form linear equation. The gradient, you can put fractions. The rest, right, I always recommend decimal point, decimal point, decimal point. 7 over 12, what is your decimal point? You tell me what you get first. You tell me what you get first. You get what? 0.5383333, right? Now, if you're going to get endless decimal point, now, for physics lab, we very chin one. Okay, I know you learn about the significant figure thing, but normally for physics lab, all right, as long as you don't go too crazy, it's fine. So normally for endless decimal point, you can put 3 decimal point also can, 2 decimal point also can. Don't go too little, like 1 decimal point too little. 5 a bit too much. So take an average point, 2 to 3 also okay. Yep. That one they don't mark that much. I mean, for this case, I'll put 3 because it's 0.5833333. So 583. And round off the value. So if it's more than 5, then you round up. If it's less than 5, then you round down. Okay. So this is how you calculate a gradient. You always make it a good habit. All right. Now next, here. If the unit for P and Q are seconds and meters respectively, P are seconds. Okay, P is seconds, and then Q is meter. They want the unit for the gradient. Now, are you done with calculating this? Because I want you to pay attention. I don't want you to be, copying whatever. You need to listen. It's always like that one. When you listen, you don't copy. You copy, you don't listen. Your brain shuts down one. When you're writing, you don't listen to me. Are you done with copying? Doing the calculation done already? Pay attention here. Now, actually, right, the real marks are, in exam, let's say we talk about exam. Actually, what happened is, if really they ask for gradient, a proper gradient questions, right? Supposingly, I separate them now. I write this whole thing is one question. Yes, a proper gradient questions, right, is 3 marks. So do you think you calculate this or that, you get 3 marks? No, you don't. Let me tell you what. do this, you get to the final answer, you only get 1 mark. Now, anybody know how do you get exactly 3 marks for gradient? Like, where does the 3 marks come from? Unit, yes. So result got 1 mark, unit got 1 mark, 1 mark. 3 marks, man. You are still missing 1. What is the third mark? Working, no. Working counted. Working counted here already. Unit say already. Unit say already. Calculation. Unit. 2 marks, man. 1 more. Exactly. Listen. The answer is triangle. What means by that? Look, you chose these 2 points, right? Now, of course, every time you calculate gradient, you're going to choose 2 points, right? So you draw a triangle based on the 2 points. Like, for example, if I'm using these 2 points, what I'm going to do is I will draw on the graph until here, and then I draw a straight line. I make sure my 2 points, right, forms a triangle. And of course, what kind of triangle is this? What kind of triangle is this? Right angle triangle, yes? Now, that means you must put a right angle here. Now, you might think this is funny, but let me tell you what. You don't draw these, they minus you 1 mark. Now, this thing got no marks, but you don't draw, they minus your marks. Yes. So how do you get 3 marks for gradient? Simple. Okay. The drawing on triangle, they give you 1 mark. Use pencil. Yes, use pencil. 1 mark. And then after that, right, calculation, give you 1 mark. And then lastly, you need to form the units. Now, why do they give marks for units for gradient? Because, right, gradient got no fixed unit one. I cannot tell exactly, gradient unit is like that, kg, no. Gradient unit every time changed. Then how? Because you got different graph, simple. Look, what is the formula for gradient again? You see, this is the good thing about learning how to form units. You don't have to memorize stuff. Exactly. How do we calculate gradient? The formula is actually y2 minus y1 over x2 minus x1, right? So generally, right, what you're doing is simply just y divided by x, isn't it? So now, very simple. If you tell me what is the unit for the y-axis? What is the unit for y-axis? Look at the question again, probably. They say P is seconds, correct? But look at the y-axis again. That's a P square. So what do you guys suppose? P is seconds, correct? P square? Exactly. Here, this is how they trick you. This is how your marks fly away. Second square. Okay, second square. Okay, second square. All good. Now, what about Q? Now, what they say about Q? Q is meter, right? But then look at the axis. What do I have there? That is 1 over Q. So what is it actually? I write 1 over Q. What do I get? You should be getting 1 over M. Now, again, when you do 1 over M, what do you need to get? When you do 1 over M, the bottom you bring up, the bottom you bring up, right? So become what? Yes. So the unit itself on the axis is different already. Here, second square. Here, meter minus 1. Okay, because the 1, supposedly if they put Q only, then it's just meter, but they 1 over Q, so it become meter minus 1. Yep. And then we come back. Now you tell me again, what is the unit for the y-axis? What is the unit for y-axis? Second square. What is the unit for x-axis? Meter minus 1, correct. Now, could you tell me when we try to shift a meter minus 1 out, what do we get? I say, the power terbalik. Positive become negative, negative become positive. Then what do we get? Second square meter. Understand? Remember like that one. Of course, you say, hey, can I put ms square like that? Normally, right, we put the power bigger in front and we put the power smaller behind. So you just leave it this way, it's fine. Yes, because this is square. There you go. Understand? So next time, make a remark for yourself. Every time, right, to calculate gradient, how do you make sure you get 3 marks? Here, first mark. Okay, first mark is triangle. Second mark is calculate plus answer. Third mark is unit. All right, the full gradient questions, they should cost you 3 marks. This is how you get exactly all 3 marks in exam. Any questions regarding this? Okay. Are we good? All of you? This is 1 over Q. So Q itself is meter, right? Then 1 over meter, isn't it become meter minus 1? Right? Minus 2 is, let's say you got something like that. If you take meter divided by second square, so you bring up, become second minus 2. Or let's say for accelerations, acceleration is meter per seconds divided by seconds. So this one bring up again, s minus 1, then you get s minus 2. No, this question supposedly they are just one question, right? In exam, they don't separate them to you. Yep. Yes. But if they separate, then this question B, you could just write answer. There's no need to show any working. Anyway, there we go. 1 mark, 2 marks, 3 marks. Understand? Anything else? Anyone not clear? Okay. Now you try. Okay. You see me saying a lot of time already. Now you have to try. Try doing number 2. I want the full thing. I want, now this gradient is 3 marks 1. Read the question properly. Okay, come, try number 2. I give 2 minutes. I go toilet for. All right. Are you done for number 2? Okay. The hint here, right? They're telling you y-axis is elastic potential energy, and x-axis is extension of the spring. So they didn't give you units, but they actually tell you what happening. So first of all, you know what is the unit for y-axis? Do you know what's the unit for y-axis? Nah, your keyword here. Elastic potential energy. Whatever energy. You say, I never heard of this before. Never mind, the keyword is just energy. You don't even have to care what kind of energy is that. Whatever energy says, they use the same unit, isn't it? Heat energy, kinetic energy, elastic potential energy, light energy, sound energy, all the energy. What unit? We mentioned that just now, right? Exactly. Joules. Correct. A for joules. Now, what about X? You know what's the meaning of extensions? Do you know what's the meaning of extension, first of all? Like, you know, when you pull a spring, it gets longer. That is the meaning of extension. And fundamentally, what does it mean by, what is this extension? Actually, it gets longer. And that is what? Now, you see, you are having a spring 5 cm. Then when you pull it, it becomes 7 cm. So may I know what is the extension? You're going to tell me 2, right? 2 what? cm. What is it actually? That is actually the length, isn't it? But of course, when we do this, right, we want to make sure that in SI unit. What is the SI unit for this again? We don't do cm, of course. What is the SI unit for extension? What is the SI unit for length? Of course, we do meter, right? There you go. So how do we calculate gradient? Now, of course, we got 2 points here. Here, right, is 0, 6, and then this point, right, is actually 3, 0, right? And don't forget, of course, we draw a triangle. First of all, based on the 2 points, we draw a triangle like that. Don't forget, label a right angle triangle. Okay, and then after that, we start calculating gradient equals to y2 minus y1 over x2 minus x1. So for y2 is 0 minus y1, 6. You could do 6 minus 0 also can, your choice. As long as you get the same answer as mine. 2. Okay? -2, sorry. Should be negative because this one is your math one, isn't it? Your graph go down, your gradient is -1. Your graph go up, positive. It's one negative. So getting negative, it's very normal. It's perfectly fine. Okay? And for this case, of course, the unit we getting joules meter minus 1. You know how do I get this meter minus 1 or not? That's why your unit for y-axis is J. Your J. Your unit for x-axis is M. Now listen carefully. Why is it not -1 there? Because you see, this is 1 over Q. That's why originally it's already -1, but this is only x. There's no 1 over x. That's why it's meter. So that's why you don't have to -1 here. And instead, when you bring this up, it becomes -1. For y, if I put fx, would it be wrong? Of course, wrong. What is the meaning of fx? This is not maths, physics are we. Every down gradient is negative, correct? When your graph go down, then the gradient will always be negative. Do I have to write J/M next? No. Actually, right, in proper one, your proper answer, I write for you to see one. That's it. This is more than enough already. Final answer, you put the unit is more than enough. Yep. So again, I got drawing from a triangle. I got calculation, I get it right. I got unit, I also get it right. $3. Okay. There, everybody. All good. Can I go on, someone? For gradient, cannot use bigger value minus smaller value blindly. No. You need to follow the formula one. If so simple, then I won't even bother giving you formulas now. You might as well just everything big minus small. No. You have to follow, because why? If you big minus small value, you're not going to be getting negative. How is that true? How is that correct? You should be getting negative because you follow the y2 minus y1. Okay. Now, of course, some of the questions I leave it to you to try yourselves. Move on. We go to chapter 2. Okay. Chapter 2. Now, regarding chapter 2, right, what I do here, it's a very simple short notes for you to study, to go through faster, right? Now, could you understand what's happening here or not? Basically, I'm telling you all the formulas. You see, number one, we have two different things here. We got distance, you got displacement. Do you know how to differentiate them or not? This is the scalar version. This is vector version. Okay. Distance, when you divide time, you get speed. And then if you take displacement, you divide by time, you get velocity. And then from here, when you take velocity, you divide by time again, you get accelerations. Yeah. So this is like a formula plus a bit of explanations. Yeah. So now again, I make it more clean to you, right? So over here, you have the formula for speed. You take distance, divide by time. Okay. Then, right, you have the formula for displacement, divide by time. It's velocity, displacement, divide by time. And then actually, right, you know what is the formula for accelerations? Do we just velocity over time? I want the actual one. I want the proper one. How do we actually calculate accelerations? How do we calculate accelerations? By right, what is it? Yep, it should be final minus initial over time, isn't it? Yes. Now, of course, you see, v is final velocity, u is initial velocity. When you minus them, they are velocity anyway, what? Right? So that's why generally just velocity divided by time. And this is exactly why your acceleration unit is ms minus 2. Because velocity unit is what? What's the unit for velocity again? What's the unit for velocity? ms minus 1. Agree? Now you can start from here on. See, you can start from here on. Displacement is s. Okay? Sorry, meter. Time taken is seconds. Meter divide seconds, I get meter per second. And then accelerations is velocity. Then you divide by another time. Then of course, ultimately what we get the ms minus 2. I notice some of you, I mean, a lot of you actually often confuse between the velocity and accelerations. I get asked a lot of time, hey, why acceleration minus 2? why velocity minus 1? There's a reason. Because they're different, what? Right or not? The way to calculate is also different. And acceleration is you take velocity divide by another time. That's why the minus 2. Now you clear? Understand? And then you see, I teach you one more trick as well. A lot of definition to memorize, right? Here, go back to this page. For page number 5, this one is your chapter 1, chapter 2, right? To be quite honest to you, all of them, do they come out? Of course, some of them higher chances, some of them lower chances, all right? I show you which one got higher chances coming out. Now, I'm not telling you confirm come out. I don't guarantee anything on. I'm just saying higher chances. I'm not saying you just study that one also. This is not tips also. All right, because I don't want to use the word tips. Later, you're sensitive one. You see the word tips, then you say, teacher say confirm come one. Never come out, then I come back for him. No, okay, I'm just telling you, normally, I see these more often in exam. Okay, now, for chapter 1, chapter 2 definition, they like to ask physics. What is the meaning of physics? They like to ask what is the meaning of base quantity, derived quantity. They like to ask what is the meaning of parallax error, and then scalar, vector, quantity, velocity, speed, acceleration, displacement, distance. The one I take is the one that is more important. And then, hey, don't complain. Like that, you still say a lot, right? Then I ask you to memorize everything on. I cut down like half for you already. All right. So these are the things that is more likely to come out in exam. Okay. I give you one more thing to remember them easier. You know, sometimes when you learn shortcut small tricks, it saves your time by a lot. Are you done with the taking? Remark already, Remark already, Remark already, Okay, good. I wait, relax. You don't have to capital letter me and wait. I wait still. Okay. Are you done by now? Okay, now look here. Look at these 3 formulas. What is the common thing between them? You realize they all, I mean, these 3 formulas, all of them are divided by time, right? Yes, quite obvious, right? Then, right, now you look at the definition of them one by one. What is the definition for speed? What is the definition for velocity? And what is the definition for accelerations? Notice something? Realize something? Exactly. So again, we have shortcut to learn these 3, isn't it? Every time, whenever you're trying to, whenever I notice if the questions, I mean, if the term, right, the formulas is actually to divide time on, like whatever divide time, whatever divide time, whatever divide time, right? Then your definition actually quite easy to remember one, because why? You can start from the word rate of change. You could start from you can start from this rate of change of whatever thing on top. For example, now, what is the definition for speed? Rate of change of distance. What is the definition for velocity? Rate of change of displacement. What is the definition for accelerations? Rate of change of velocity. It works for all 3. Then you just have to remember one now, isn't it? So now I save your time by 3 times. Okay. Because only chapter 2 Later on in the future also, you will get another formula, is another one. Okay, F equals to mv minus mu over t. Then also rate of change of momentum. You don't learn this now, so I don't care. I roughly estimate. Yeah, but you get it. So this is simple trick. that helps you to remember your definitions for speed, for velocity, for accelerations. Okay. Then after that, right? This one is only a reminder for you, okay, regarding this linear motion equation thing. Formula, I give it to you. But there's an error I need you to change a bit. You look at this, number 2. This is, I don't know why, I think auto-corrected. This one by right should be 1/2. Right, got 1281. That one's a bit crazy, right? So that one is actually 1/2. The slash like missing out, I don't know why. Okay. So this one is your linear motion equations. Because I know you're going to forget anyway, so I give it to you in case you need it. You can refer here. All right. Now, normally formula sheets first time exam, don't expect. Okay. Chances are you're not going to get any of them. Yes. So what you do, very simple. The notes I gave you, this seminar notes, right? Inside got many questions, but practice with them. The more you do, you get familiar. And then the day before or the night before your exam for physics, of course, you read through this. Okay, half an hour also can, 1 hour also can. Before exam, you memorize the formula. Then once you go into your exam hall, right, straight away right inside, right on your test paper, then you can create your own formula sheets already. Yeah, but these methods only works for first term exam or because when you go to second term, third terms, right, they start to have more chapters. Then a bit waste of time for you to go and list down every single formula for all, like, from chapter 1 to chapter 5. What's the point, right? So this thing works now, but not like what? Okay, not like second term. I don't recommend now. I recommend you probably try to remember eventually. Okay. Now the formula, I got time, I come back for you, but I want to talk a bit about ticketing because I think you guys are confused about this more often. Now, have you done this before? School experiment? Never? Huh? How can? Like this one confirm do one actually. Hello, by right supposed to do one. Not yet lah. Not say no lah. Not yet. Cannot be lah. Supposed got do, right? Done already. How was it? Fun or not? And then confirm got this one curious kid go and tekan the on button without your teacher tell you to so, or when your teacher is explaining the experiment, talking about the experiment, the teacher talking in front and then like at the back. And then confirm got this situation where you didn't stop the trolley from moving and then it slide down into the sink. You slide all the way and drop inside the sink. It's okay, everybody does that. Okay. Now come here. How your one got stopper so cool one? Normally it's like that one. The experiment is you got this sticker tape and then they put a slope here. And then the trolley is here, man. So trolley attached to the tape, trolley slide and then they pull the tape. Then normally here is the sink and then just go inside. Anyway, here. Since you are familiar with it, so I think I suppose you can know roughly a bit. Okay, you know exactly what happened. See, and you know how it works already. Now, for ticker tape questions, let me make it very simple for you. I just need you to know how to do 3 types of questions. Yes, for ticker tape questions, they only ask what? They give you one tape, they ask you calculate velocity. They give you one tape, they ask you calculate accelerations. They give you one tape, they ask you calculate, they give you many tapes like this one, chart. Then they ask you calculate accelerations. All right, so again, for ticker tape questions, like that, for ticker tape questions, right, normally we got 3 questions only. All right, what is it? Number 1 is, there will be one tape, okay, they give you one single tape, then they ask you to calculate velocity, okay? Then there will be another situation is, they give you one tape, they ask you to calculate accelerations, all right? Now, I write in words, easier. So you got single tape to calculate velocity, and then single tape to calculate accelerations, and then you have the ticker tape chart. Okay, many tape put together become like a graph. They ask you to calculate acceleration as well. Okay, so you can do all these 3, then you settle for your ticker tape. You can move on. All right, now that's fine. So this is how you know exactly what is the important thing. What are things that you need to know before you go on. And frankly speaking, yes, we have 3 different questions, right? But how many formulas do we actually need? How many formulas do we actually need? Single tape, calculate velocity. Single tape, calculate acceleration. Single chart, calculate acceleration. You realize one thing, right? Ultimately, You are using how many formulas only? You only calculate number one, velocity, how to calculate. Come, formula. I need the basic one only. You can take use basic formula one. How do you calculate velocity? Displacement over time, correct. How do you calculate accelerations? Whether single tape or ticker tape chart, how do you calculate accelerations? V minus U divided by time, correct. And that's it. You remember this? You settle. And now let me ask you a question. What is the part that you normally confuse the most? Where is the part you normally get stuck? I suppose it's here, right? The time part, right? Because why? You say, hey, why? Sometimes ask me calculate tick. And then sometimes ask me calculate jump. So when? Now, this one you write down first, I explain to you, okay? Whenever you're trying to calculate time for velocity, you calculate number of ticks. Okay, you calculate the number of ticks. Later I explain. You write down first. Okay. Now, whenever you try to calculate acceleration, whether it's single tape or chart, right? You calculate number of jumps. Okay, I explain to you afterwards also why the jump and everything. Okay, you write down first. Now, first thing first, to find time before the tick, before the jumps, what is the thing you need to know? You need to know how many seconds exactly you are now. Do you remember the frequency thing? They will tell you, right? The ticker tape is running on what frequency? The ticker tape is running on what frequency, right? Now, here's the thing, normally, listen carefully, normally, usually, the ticker tape, they are running at 50 hertz. Okay? Could I change? Can. All right? The question will mention one. Now, listen, if the question didn't say anything, you assume 50 hertz. And if they want you to use different frequency, right, they will say, the ticker tape 40 hertz, the ticker tape 30 hertz. If not, right, 50, default setting, 50 hertz. Now, do you remember what is the meaning of this 50 hertz? Do you recall what is the meaning of this 50 hertz? Means what? 1 second, the machine will 50 times. Exactly 1 second, the machine will take 50 times. They mark 50 dots in 1 second. And of course, do you see 50 dots here? Do you see 50 dots here? 50, 50, of course not, right? That means what? Does not equal to 1 second. If you see 50 dots inside, then 1 second. If you don't see 50 dots, then lesser. Right now, then how do you do? Find out how long does it take for the machine to do one time. Right, like for example, imagine I tell you, 1 ringgit can buy me 50 candies. Okay, 1 ringgit can buy me 50 candies. May I know 1 candy how much? What do you do? I cannot finish 50, I want to buy 1 only. So what do you do? 1 ringgit, you divide by 50, right? So this is the thing here. Every 1 second, now always remember, frequency is always count by 1 second one. So when I say 50 hertz, means 1 second, 50 dots. When I say 40 hertz, means 1 second, 40 dots. Now always 40, 30, 20 or so must be 1 second. So simple. If 1 second can do 50, then of course, if I only want 1 tick, all right, then I do what? I take 1 second divided by 50. That's why I get 0.02. Now, I don't want you to memorize this 0.02 because why? Must it be 0.02? Now, this one, it only be 0.02. It's because, right, you are running at 50 hertz. You take 1 divide 50, that's why the 0.02. You get it? But let me ask you a question, sir. What if I got 40 hertz? What if I get 40 hertz? Do I still get 0.02? If the machine is 40 hertz, means what? 1 second divided by 40, correct. If it's 40 hertz, then divide 40. If it's 30 hertz, then divide by 30. 1 over 40, what is your time? You press calculator, 1 divide 40, what do you get? See that? There you go. And 0.025. But of course, default setting, if the question never say anything, right, straight away 50 hertz only. Straight away 0.02 only. But must it be 50? Not necessarily. Default, yes. Can. And then normally you see, right, I normally say number of tick instead of, notice I never say, time taken for 1 dot. I say time taken for 1 tick. Now, because why? The 0.02 second, how do you count is like that one? From here, the machine, from here, you take up and then you dot 1 more time. It will took you 0.02. So instead of putting dots, right, instead of counting the dots, right, what you do is you count the ticks. As in what? You start putting ticks in between the dots. Because why? Look at this. You got 1, 2, 3, 4, 5 dots. But supposedly, right, from here to here, 0.021 time. And then 0.02, 0.02, 0.02. How many 0.02 did I do? You see, I got 1, 2, 3, 4, 5 dots correct, but 0.02, 0.02, 0.02, 0.02. Only 4 times, isn't it? Exactly. So what we do is we don't calculate the dots, we calculate the tick. We calculate the tick, we calculate the tick. Got it? Now, first thing first, the frequency, what's the meaning? Second, now they will also tell you one thing. They will say this machine, right, is running at 12 volt AC. Do you recall this thing? What does it mean by AC? Agam, what does it mean of AC? I think you learned this in Form 3, I think. Form 3, Form 2, Form 1. AC stands for alternating current, right? What is the other one? The counterpart of AC, the opposite of AC. Yep, that will be DC. What does DC stand for? Direct current. Now, then the question sometimes they will ask you one, why must I put AC for the ticker tape? Yes, you need to put AC for the machine one. And why is that so? Okay, never mind. I know you probably get a bit stuck here. What is the difference between AC and DC? Like, you know, when we say AC, DC, like, what is the difference between them fundamentally? DC, right? You know why is it called DC? You know, direct current. Basically, right, the current do this same direction all the time. One round, one round, one round, one round. Okay. Now, what about AC? You know why is it called alternating, right? Every time they go one round, they will switch directions. They do this one round and then come back. In the circuit, they do this. That's why I call AC alternating, alternating, alternating. DC, DC, DC. AC, AC, AC. Now you think about the machines. What do ticker timer do? What do the ticker timer do? It takes. What's the meaning of takes? Okay? Think about the arms. What does the arm? What is happening? What is the movement of the arms? Then smart guess. How many directions am I doing? And you notice the direction is going opposite way, right? Then how am I supposed to do this? Do I supply AC or do I supply DC so that it will do like that? Of course, you put AC, am I right? AC, why AC? You turn one round, AC, one time, go down. Switch direction, come up. Can follow now? What happens if you do DC? That's it. The thing we're not going to do this, you know, the thing will just do this and then you don't get dots on your paper. You just get one line drag all the way over. As that's a problem. So that's why we do AC. You understand? Yes, exam ask one. So if whenever they mention about why the AC, simple, the answer is to produce continuous ticking motions. Okay, it's to produce continuous ticking motion. Of course, please write down if you want to. Now, to produce continuous ticking motions. Get it? Something like that. I mean, you can say so that the ticker tape can go up and down, but you know, but that sounds a bit funny, and then a bit like a pasar language, right? So this one sounds more cool, to produce continuous ticking motions, more atas, the word. Okay, there you go. And so also good. Let me wrap up the whole thing because I know that I don't have too much time left already. Okay, and then if you're rushing to go anywhere else, it's okay. You don't have to wait for me. Of course, you know, if you want to learn more, then let me finish up. Okay, are you done? Can we go on, Jama? I wrap up a bit, still a bit more only. A little bit more because I want to show you how to calculate. That's all. Can. Now next, now single tape, we calculate velocity. Now actually for single tape to calculate velocity, very simple one. Because why? Let's say this is the questions. All right, they will give you the tape, and then they will tell you the length. Now the last thing you worry about is the length. Confirm they say one. All right, so they will tell you from this dot all the way randomly pick here. Okay, from here to here. Okay, then from here to here, we have say 12 lah. Okay, this thing 12 cm. And then they will tell you the machine running at frequency 50 hertz. Okay, this one they will tell you one. Okay, and then calculate the velocity of the object. How do we do that? Now, every time you just remind yourself, if I want to calculate velocity, I take displacement over time. Okay, then you ask yourself, do I have S? Do I have T or not? I want to find this guy, I must have two. Number one, do we have value for S? I suppose we do, right? Given to you. Last thing you worry about the value for S. They literally give it to you, right? How much? This will be the 12 cm. Okay, now divide. How do we calculate time again? For velocity, do we calculate tick or do we calculate jump? For velocity, do we calculate tick or do we calculate jump? Velocity, we calculate? Yes, we calculate tick, correct. Now, before that, 50 hertz means what? This one first, we translate. 50 hertz equals 1 tick. How long? 50 hertz means 0.02 seconds. Okay, then you start counting the ticks. Now, when we start counting ticks, right, what happened? You see, you put ticks between the dots like that. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, do we stop here or do we continue counting? 11, 12, 13, 14, 15. Now, what is your tick? Should be 10 or 15? This is logic questions one. Your 12 cm until where? They give until where? You count until where? Exactly. Why do you include this inside? It's like, imagine you go for 100 meters sprinting. Do they continue counting your time after you pass the finishing line? No, right? They start counting the time when you start running. They stop counting when you stop running. So is this one here until 12 cm until here? Then of course I don't care now. They do this one actually. They will obviously give it extra. Confuse you. They give until here. Now literally, if they say the 12 cm is here to here, then it will only be 2 ticks. You understand what I mean? But in this case, we got 10 ticks. And of course, don't divide 10, 10 tick means what? You need to multiply time 1. Every tick needs 0.02. So I take 10 multiplied by 0.02. There we go. How much do we get, by the way? 12 divided by 0.2. What's the answer? We get 120 cm per second. Now, I know I told you, hey, I thought we're supposed to SI unit all the way, right? Now, normally, yes. But for ticker tape, because the value you normally get very small. Right, getting what 1 cm, 2 cm, 12 cm like that. So it's fine to leave them in cm unless the question mentions specifically. I 1 meter, and then you convert. If not, right, since you put cm here, all right, and then seconds here, then it's okay to leave it in cm per seconds. Get it? Oh, sorry. 60, my bad. I know this. My bad. I thought it was 0.1. No, sorry. 60, correct. 60. My bad. I didn't know this. I thought it was 0.1. Okay. No, it's definitely my error. Okay. I admit one. I'm not gonna give you those nonsense. No, I test you whether you understand or not. I test you whether you pay attention or not. Oh, I calculate wrongly. Okay, I'm sorry. Questions? We are good. Can we go on? No, that's it. To calculate velocity, that's all. Take the displacement, calculate the tick, multiply the time. Now, your problem, I suppose, is when it comes to calculating accelerations, right? Now, for example, here, we got the single tick questions. Okay, now what if, right, they give you 1 tick, right? Now, could you tell the difference between this one and this one? You look at the dots, what is the thing that you realize? Look at the dots. This one and this one. You realize this one is all the same distance, right? That's why this one, they only ask for velocity because you're having the same distance, meaning what? Your velocity is constant. You got no acceleration here. This one, right, you could see the distance between the dots are different. Okay? And then, of course, the questions, they will give you like, from here to here. Okay, 1 dot to another dot. This one, say we give it 3 cm. You don't worry, this one you don't have to pick up yourself. They will let you know. Okay, they label nicely one. And then after that, from here to here, this tiny little gap, we make it 0.5. Okay. There we go. So we got 3 cm here, we got 0.5 cm there. Like that. And now, of course, when you got different space means what? When you got different distance, meaning what? That means you got different speed, right? You could be either getting faster or either getting slower. Make sense? Now, question's very simple. Are we having accelerations or decelerations here? Are we getting faster or slower? This diagram. Are we getting faster or slower? Faster or slower? Faster or slower? Faster or slower? Answer is slower or faster. Answer is faster. Faster. Now, listen now. No, the 3 cm and 0.5, I give on the question, give it to you. Don't worry. I don't know why you all always are stuck with this thing. Like, you cannot accept the fact that like this one, give it to you. Don't worry. Yes, you constantly say, huh? What I need to know about the 3? Relax. They give on. Chill. Okay. I didn't put inside only at first. Yes. 3 cm, 5 cm, 0.5. And also the frequency given to you, 50 hertz. And now we come back. We're having accelerations here. How? Come, not decelerations. Do you see the arrow here? You know what's the meaning of direction of motion? As in how they pull the tape. As in how they pull the tape. So when I have this arrow, right, that means I'm pulling the tape to the right side. And yes, where they point means where they start. Now, very simple one. No need memorize one. In exam, you say, I forgot, then how? Simple. You bring your test paper, and then, right, you put your pencil, don't do pen now, okay? You pretend you are the machine. You pull your test paper and see. Yes, now, if you were to start here, and then you pull the paper to the left, you're going to get markings on the left here, isn't it? Sorry, you put the paper to the right, okay? You put the paper to the right. It's supposed to drag all the way. Like, you know, your marking going to be here. There won't be any marking here. If you start from here, and then now, right, you put a pencil here, you put a pencil here, and then you pull your paper to the right side. You get all the marking already, right? So where they point to the right, means the right side here is your starting. They point to the left, means the left side is starting. Understand? So actually quite easy to understand also one. They point where means where it starts. But actually, if you want to understand more, you want to find out why is it actually, you can try pulling the paper. And then you notice one. Pull the paper to the right while you hold your pencil there. You notice one. You need to start here, then only you can get all the markings. Yep. Okay. Now, so of course, starting 0.5, ending 3 cm. Are we getting faster or slower? You see, you can travel more distance. Faster? Slower? Of course, faster, right? Next thing here. Next thing here. Come, follow. You want to calculate accelerations, right? V minus U over T. Now, what does V and U stand for? What does V and U stand for? V is final velocity, U is initial velocity, right? Can I take final as in the 3 cm straight away put inside? And then initial, can I take 0.5 and minus? Can we do that? Could I do that? I got so easy, right? Now, why is that so? Look, what is the meaning of V and U? Come, what is the meaning of V and U? V stands for what? Final velocity. U is initial velocity. And what is this 3 cm? That one is a distance one. How can you take distance as your velocity, right? If you could do that, then why I put velocity? I might as well put S minus S and can already or not? Yes. So what you do, now velocity, they don't drop from the sky one. You need to calculate yourself. And because the question is always like that, they are like accumulative. What you learned just now? You learn how to calculate velocity, right? Now you apply. Yes. So before we calculate acceleration, first thing we do is what? We calculate initial velocity. We calculate final velocity. Now, regardless, initial or final, they are both velocity. Velocity means what? Displacement over by divided by time. So for the starting, right, the initial displacement travel 0.5 cm, and then I divide 0.02. Can I know 0.02 multiply how many? Can I know 0.02 should multiply how many? You look at the 0.5, this is 0.5. Now, look. If you were to calculate the whole thing like that, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, the whole thing we have 10 ticks, correct. But the 0.02, to calculate the 0.5 cm, do you multiply 10? What did I say just now? Like, did I calculate? I mean, did I multiply 15? You only multiply 10. Why? Because the 12 cm is 10. Then look at the 0.5 again. Do I multiply 10? Of course not. Because why? Only got one thing, right or not? The 0.5. That's why 0.02. You get it? Just one. Don't need multiply anything. And of course, press calculator. How much you get? 25, I suppose. Is it? Double confirm for me? I don't know. I guess one. And later you calculate. Calculate again also. Wrong then how? Double confirm. Press calculator. Now for final velocity, displacement over time. And this one I get 3 divided by 0.02 also. You know why, right? Because only got one tick, right? Then 0.02. How much do we get? 150. Once you got the final initial velocity, then only now you officially substitute inside. Acceleration is final minus initial over time. So I put inside my final velocity is 150. My initial velocity is 25 divided by. Now, for now, right, the time taken here, do I need to calculate the whole thing? Should we calculate the whole strip now? Of course, yes, Mara, or not. Because why? Now, acceleration is the whole thing, and you see the minus, right? The v minus u, you can see the negative as like dash from v to u. It's everything from final to initial. But then here you pay attention, it's very important. Now, to calculate velocity, we calculate number of ticks, no problem. But whenever we're calculating accelerations, to calculate the time, what do we calculate? To calculate the time, what do we calculate? We calculate number of jumps. How to jump, right? Now look at this. Now, how many ticks we have? First of all, how many ticks do we have? We have 10 ticks, right? But when you jump, right, look at this properly, and you jump, right, you do this. One tick to next one, jump one time. You follow, from one tick to next one, jump one time. 2, 3, 4, 5, 6, 7, 8, 9. How many times did I jump? Exactly. You only jump 9 times. Now, one thing, because I know next thing you start thinking like, hey, then does it mean every time when I calculate jump, right, I can calculate ticks and then -1? Now, this is a very dangerous mindset. Don't do that. You just remember one thing. You want to calculate accelerations. This one here, you calculate number of jump. Okay, don't calculate ticks and then -1. Later, you know why. Okay, so when you do this, right, you jump from tick to tick. So I got 10 ticks, yes, but when I jump like that, I only got 9 jumps. So 9 multiply how many? Now, when you jump, right, what do? You jumping from one tick to another tick, right? One of these is 0.02. So that's why if I do 9 times, right, and I'll just take 9 multiplied by 0.02, like this. And then what do we get? Calculate for me, final answers. Of course, you get a very big number. I want 2 decimal point. How much? 694.44 cm -2. Sorry, cm lah. CMS -2. Okay. No. This one you are still calculating velocity. That's why this one you are still counting ticks. Only for this formula, this time you need to calculate jump. Yes. Now I quickly finish up the whole thing, and then later on, you got any question, you can stay and ask. If not, then I need to let you go already. Now, what if I get chart? See, chart is actually easier. You follow me, you pay attention, don't copy anything, just look here. Now, chart is actually easier. Why? You see, this one is 10 cm. This one is 2 cm. Now, why do I say chart easy? Because, right, you know, this chart don't have directions, right? Because this is like a graph. Whatever it is, this is definitely starting. So I don't care whether the start, right, the tick there is long or short. The first one confirm is starting. Yes, the last one confirm ending. Yep. So again, we need to calculate accelerations, all right? So what we do, A equals to V minus U over T. But the problem is, again, we don't have B and don't have U. Okay, final velocity, initial velocity, they don't drop from the sky one. You must know how to calculate yourself. So how do we calculate that? Simple. We put aside first. We find out initial velocity, displacement over time. We find out final velocity, displacement over time. Now, initial is the beginning stick. What does it say? It put 2 cm. Then I put 2. Divide by. Now here, do I still take 0.02 only? Here's the question. Just now, we divide 0.02 only. That is because the 0.5, it's only one tick inside. But look at this. The 2 cm. Do we have just one tick? Of course not, right? Let me calculate for you. Here, 1, 2, 3, 4, 5. 5 ticks. And you're probably thinking, hey, I thought you're calculating U. I thought we're looking for U. Then why are you counting the V1? Simple. This one 5 ticks. Then I guarantee every one of them 5 ticks. This is how they cut the tick. Confirm same number of ticks. Yes. So don't sometimes this one too small to see, right? Very simple. You look for the longest one, you count. Inside got 5 ticks, right? Then the rest confirm 5 1. You're not gonna get like 5, 4, 3, 2, 1, 5, 7, 2, 1, 7. No. Basically, 5 means everything 5, 10 means everything 10. Could be different, but it will be the same. Like 7, then all of them 7 ticks. 10, then all of them 10. Okay. So here, because inside got 5 ticks, then I take 0.02 multiply by 5. And then of course, I get this one, 2 divided by 0.1, we get 20. Now, final velocity, same thing also. It will be 10 divided by 0.02 multiplied by 5, which is 10 divided by 0.1. And we get 100. Once you got final, once you got initial, right, we substitute inside. The final velocity is 100, initial is 20, divided by. Now here, how do we jump again? Now this one, listen carefully. Do not jump one by one. For ticketing chart, right, they cut nicely for you, right? You go and do like this, 1, 1, 1, 1. Now, what if, right, inside got more than 5 ticks? What if inside got 10 ticks? And then what if I got 10 ticks? I got 10 of this. And then every one of them inside got 10. Then how long you need to keep jumping until, oh, you know. Now, when they cut nicely for you, look at how I jump. Okay, I do this. I jump from one tick to another tick, consider one time. And then one more, and then one more, and then one more. How many times I jump? I jump 1, 2, 3, 4. I jump 4 times. See that? And then now you pay attention. When I take 4, right, what do I multiply? You see, just now, right, 9 jump multiplies 0.02. Why? Because you are doing one tick by one tick. You're jumping one by one by one. So 0.02, 0.02, 0.02, 0.02. But now, right, how do we jump? Inside one of these, that is 5 ticks. And we are doing 5 by 5. Realize that? 5, 5, 5. Now, a simple question is, what is the time for this thing? What is the time for this thing? Five ticks. Every tick 0.01. 5 of them. The time taken will be 0.1, right? So now, right, what are you doing? 0.1, 0.1, 0.1, 0.1. You get it? So now, right, it becomes 4 multiplied by 0.1. Yes. So the difference is a bit here. And of course, finally, we get 80 divided by 0.4. What do we get answers? Suppose we get 200, right? CMS negative 2. Yep. Now, one of the way you can double check your answer, always the time we used to multiply the jump for accelerations, right? Now here you see 0.02. You will notice they match with the time you used to calculate your velocity. Yes, you will notice they match with the time we used to calculate velocity. Now, same thing here also. When we take 4 jump multiplied by 0.1, and then you realize also that is exactly the time we used to calculate the velocity as well. So you can use this as a checkpoint, whether you are doing it correctly or not. And there you go. This is how you calculate. Okay? So let me summarize a bit. What happened is, take questions, right? I only need you to remember how to calculate velocity and accelerations. So whenever you calculate velocity, you calculate the ticks. They give until where, you count until where. You don't have to calculate the whole thing, but they stop here, then you also stop here. All right. And then for accelerations, right, we calculate the jump. And for the jump, right, it depends on how you jump. If they cut nicely, you jump from tick to tick. If not, then one tick to one tick. Yes. Now, if you worry, you confuse between the tick and jump, right? I teach you one more trick also lah. You see, this is the ticker tick, right? And then you got many dots inside, right? Now, if they ask you calculate velocity, what do we calculate? If they ask you calculate velocity, what do we calculate? You calculate number of velocity, tick or jumps. Yes. How do you walk now? Look at the tick. Tick. What does it look like to you? You zoom in. And then you zoom in some more. What does it look like to you? This thing looks a bit like V, isn't it? That's how I remind yourself. Because the V, displacement of 1. Okay, so next time, right, whenever you calculate V, you remind yourself this is tick. Then you calculate tick. And of course, the other one, it will be jump. Understand? Now get it clear? So the V shape looks like tick, then you calculate tick. The A means jump. Okay. So that is exactly the idea. Okay. Any questions over? Okay. Can. Now. Let me final up everything. Now, a few things, because I think some of you, you're not my students, right? If you want to reach me, right? You could go to Instagram. This is, you search for this. Okay. And of course, you go to YouTube. There are some video that, kind of helps you as well, especially if you're having like motion graph kind of exam syllabus. Same thing, search for this. And of course, I hope that you all learned something new today. I hope that you all managed to all these things managed to help you to revise my exam, managed to help you in the exam. Okay. If you have no questions, then I think I suppose I'll stop here lah. And the answer it will be uploaded to the Google Classroom you're inside now. I mean, whether you're new students or whether you're a student or not lah. And if you have a question, you can stay later. I'll explain whatever you want to ask. Okay. All right. Bye bye.